So here's a similar situation. I have a cubic inequality, but watch what happens when I have a root of higher order. So a root that shows up twice, a 0 that happens twice and I find it when I factor. So this is x cubed minus 4x squared plus 4x is greater than 0, so is positive. I start by factoring. I notice that there is a greatest common factor of x, so I have now x times the quantity x squared minus 4x plus 4 is greater than 0. Inside those parentheses, I have a trinomial that factors. This is x minus 2 times x minus 2. I want that polynomial to be greater than 0. I want it to be positive. So now that I've factored, I notice that this was my degree 3 polynomial. I only found 2 distinct roots. I found a 0 and 2. So the degree of the original polynomial was 3. I did not find 3 separate roots. So my sign chart, my sign analysis is going to look a little bit different from some of the other ones. Instead of my number line changing sign at each root, I will have a place where I'll have one root, the double root, where the sign does not change. So remember, our technique here is to choose an x on each interval. So what if I let x be something less than 0, like -1? That's a -1. I'm going to have a negative, because x would be -1. -1 take away 2 is -3, which is also negative. Notice what happens here. No matter what I pick for x, this factor is going to be exactly equal to this factor. So I'm going to have a negative times a negative times a negative, which makes a negative result. What about when I plug in something on that second interval? Let's let x equal +1. So that would be a positive. 1 take away 2 is negative. That would be negative. The second factor is exactly the same, so that's also going to be negative. That's an equal sign. So I'll end up with a positive times a negative, which would be positive. I have a lot of students historically who at this moment would say, oh, it's going to alternate. And they just fill in that last interval as negative. But remember, we did not find 3 separate roots for a degree 3 polynomial. So we have to be really careful when we check. So notice that when x equals something bigger than 2, something from that third interval, this would be positive times 3 minus 2 is 1, which is positive. 3 minus 2 is also positive. And I'll have a positive factor times a positive factor times a positive factor. The result is going to be positive. That's plus sign. So one way to think about this is, as long as you're willing to check a number from each interval and you check it carefully, you won't go wrong. If you get to the place where you're starting to notice shortcuts and starting to notice that at every root the interval changes sign, that's not true at a place where there is a root of an order that's an even number. So x minus 2 was a factor twice in our polynomial. We call it a double root. If there's a double root or a root of degree 4 or 6 or 8, there will not be a sign change at that root. So here, if my goal was to say, for what values of x is this greater than 0? Greater than 0 means positive, and my final answer would be on the interval from 0 to infinity. Or equivalently, I could say 0 is less than x, which is less than infinity. Or x is greater than 0. 3 answers all mean the same thing. Feel free to give any one of them. So I'll bring this paper for you to class tomorrow if you feel like you want to get started. If you can do, let's see, these 4 problems, you're probably in good shape. I don't need you to do probably any more work on this. Whoops. So that was number 1. Let's write it out. Number 1. Oh, goodness gracious. So if you can do numbers 1 and 9 and 12, and I'll post the answers in class tomorrow, you're in good shape. If you struggle with those, then we might want to rewatch some of the videos I posted and come to class ready to ask questions.